Station models. Okay, so this is page 13 of the reference table, and it has a lot of stuff on station models. Here's an example here. Now, what station models are used for, just a little background, is this is how they get a lot of weather information, sort of like in shorthand on a large map, that you can then see what is going on with the weather, see what's going on now, make the prediction. This is a key tool for meteorologists, and you often need to know just sort of how it works and how to make one yourself or interpret it yourself. So here we go. This is from the reference table. This is to give you an example, and then this here tells you so much about it. So a lot of times when you have to either construct your own station model or get information off it, you go here and you look up what all of this is. Key thing, these are in Fahrenheit. There's no units on here ever. We never write units on here. And you rarely, like these don't have any decimals. That someone has a decimal. These don't have decimals either. One thing I want to point out here is the wind direction. So this thing represents the wind direction. And kids often don't know if it goes that way or that way. And the wind direction, you can tell down here because it says from the southwest. So it goes this direction. It goes here towards the circle. Use this as a guide. You don't really have to memorize it. Use this as a guide that it goes from here to here. That's key. Okay, this symbol in this area here represents present weather. In this case, this example that they give is this symbol here, which represents snow, but some other symbols, they're on the bottom of that same page in the corner, and you have sleet and fog and thunderstorms and hail and smog. Sometimes you have to use those, rain and drizzle, and that goes in that general location, so know that as well. Now, here, okay, we have 4 different station models from 4 different cities. Now, the first question I want to ask is this. At which one of these, based on what you see here, is precipitation most likely to occur in the next few hours? Okay. Now, the good way to look at this, or the thing to look at here, is the temperature dew point comparison. The closer they are together, the more likely you are to have precipitation. That's a key thing. Make sure you know it. Okay. The closer these numbers, the more moisture in the air, and therefore the more likely it is to have precipitation. So the answer here, which is closest, most likely to have precipitation next few hours, is going to be Utica, because it would only need to go down 2 degrees Fahrenheit for the air to be 100% saturated. In that case, again, you get clouds or you get fog forming if it's on the ground. The other thing is wind direction, so we'll just do some wind direction examples, and wind speed. So the wind speed here, these are feathers here, and they're kind of discussed right here, that a whole feather is 10 knots, and half of a feather is 5 knots, and a knot is a little more than a mile per hour. So let's look at the first one, Chicago. Well, first of all, the wind is going this way from the northwest. There's 1 full feather there, so that's 10 knots. So wind is 10 knots from the northwest. Detroit, Michigan, same direction from the northwest, but now we have 10, 20, plus 5, 25 knots from the northwest. Buffalo, New York, this is the same direction as here. It's from the southwest, and then you have 10 and 5. That is 15 knots from the southwest. And here we're in Utica, and it's going this way. Okay, so it's from the southeast, 10, 20 knots right there from the southeast. Know it. That is a common thing that we see on tests. Okay, now this gets a little more tricky, that we're doing atmospheric pressure. If the question is asking, what is the atmospheric pressure for this example here? Well, this is the barometric pressure is labeled right here. Now, that's not it. It's this sort of shorthand, okay? So don't write 978. That is not the barometric pressure. It represents something different. So this is how it works. Okay, so this is the general rule. If this 3-digit number is above 500, you add a 9 in front and then a decimal. If it's below 500, you add a 10 in front and then a decimal. Now this I found hard for students to remember. So basically, what I always say is just know something about 5. So I know something about 500 is a number, and then I add a 9 or a 10. So if you know that, you're good. I'm going to show you how to do it. So basically what you want to do is you say, okay, so it's 978, and write that down. If you have to write it in your answer booklet or something, 978, and then as long as you know something about 500, I'm adding a 9 or adding a 10, then use this as an example, okay? This is the section of the reference table. This is 196. Is that above 500 or below 500? Well, it's below 500, and see what gets added in front. A 10 gets added in front. So that tells you the rule. Okay? Below 500, you add a 10, and you have to figure out the converse of that or whatever. Or if it's above 500, you have to add the 9. Because barometric pressure is always in the high 900s, low 1000s. So what you do, you said, okay, so now I have to add a 9 in front. You do that. Now, that's not the pressure because you need to add this decimal between the last two. Therefore, your final pressure is 997.8 millibars, which again is very different than that. So that's key. Let's do another one. Okay, in this example, it is 0, 1, 2. Always has to have 3 numbers here, so that 0 is a good placeholder. It needs to be there. Again, is it above or below 500? Well, that's below 500. You use this as an example. This is below 500, and what got added? A 10. So we have to add a 10 in front of that. First, write those 3 numbers. That's key. Trust me. Write them first, and because sometimes zeros get left off, I've seen that happen a lot too. Then add the 10 in front, but you're not done. A decimal place goes between the last 2 numbers, and then millibars is the unit, and there you go. So the real air barometric pressure is that right there. Okay. Oftentimes, it's common that they give you something like this and you have to add information to it. Temperature, dew point, or what's the present weather symbol, and you got to put it in the right spot. And the atmospheric pressure is often one of those things. So if the atmospheric pressure at this location is 1004.5, the way to add it on, we got to know it goes right here, and it's just the last 3 digits, no decimal, it goes on there. So it looks like that. That's it. The 0 needs to be there though. 0 needs to be there, has to be 3 digits, or else it's wrong. And let's do another one. If, in this case, it's 986.1 millibars, again, last 3 digits, drop the decimal, it's going to look like that, 861.